Welcome to UARC. Bruce usually does this, but he couldn't be here tonight, so I just got volunteered. Let's see. Anybody newly licensed? No? Anybody upgrade? Thank goodness. No, we don't accept downgrades, so. Okay.
About visitors there.
Oh yeah, any visitors, new people? Introduce yourself.
Dan, KJ6, JZU.
Dan, welcome. You visiting, moved here?
I'm from the mission here, been here for over a year, be in here another 10 months.
Okay, great. Glad to have you. Oh. Jed, welcome. Okay. Got another one? Oh. Okay, welcome. Well, this is. I didn't hear all of it. So. KM6, DQD. TQV, CQZ. Acoustic sync is stinking here. Okay. Well, welcome. Tonight's our annual Homebrew Night where people bring stuff that they've made to show it off, and exhibitors get their choice of fabulous prizes over here. And okay, we got announcements.
I didn't have time to do this live, so you're going to have to wing it.
You got classes going, Morris? Classes?
Okay, we will be teaching technician, general, and extra classes starting in January. The Mondays in January, or starting in Monday, they run 9 weeks. And the technician and general classes will be on Zoom, and the extra class will be in person. The technician class will start on the 16th of January. That's a Monday. The general class will be on the 18th, which is a Wednesday. They'll run for 9 Mondays, 9 Wednesdays. And then the extra class will be on Tuesdays, if there's enough interest. And that will be in person, probably at my house. And it runs for 16 weeks. So if you're interested, please send me an email. I respond to emails and almost nothing else. Food. But send me email to my call sign AD7SR, that's Alpha Delta 7 Sierra Romeo at ARRL.net. Yes. We will have elections. The elections will actually be in December. We will announce the slate of candidates next month, and we will. The one that we have the most contention for, at least at present, will be the editor, microvolt editor position that will replace Gordon Smith from. Anyway, sorry, I can't even talk about it. Anyway, we right now, I believe, have 6 candidates for microvolt editor. They will be writing a short article, and we will put those articles on the website. Please review them, because you will get to choose between the ones that you like best for the microvolt editor. Whichever one gets the most votes is the one that will be the editor for next year. Okay, I think that's all I have, I hope.
Yeah, he did. Okay, the Rocky Mountain Region ARL convention was last weekend in Cheyenne, and Pat, you going to come talk about that? Give it.
Right here. Great.
Okay.
Just to let you know, in the past month, I've had a chance to go to Connecticut for a few days with the ARL leadership, as well as the division convention in Cheyenne. Let me give you a couple highlights. Just take a quick 2 minutes here. One of the things the ARL has pointed out is we're having a leadership crisis. That may be part of it due to the age of our membership. At the same time, the question comes up: Are we mentoring those that are younger and preparing them for that kind of a role? So that's just something to be aware of. They pointed out we need to start treating each other better. We don't need bullies. We just need to create the unity, a positive culture, embrace the young people, and support STEM, and let's build that groundwork we need so desperately. Division convention, it was a good event. The majority of speakers there came from Utah. It was very well supported by us, and it's a good thing because they don't have a lot to pull from in Wyoming, but it was a great event. The ARL president, Rick Roderick, was there, and he gave an interesting challenge, and I'm going to pass that on to you, and that is to find one new person to bring in to ham radio in the next year. And the other one was to find one person to reactivate. So that'll help strengthen our ranks. A common theme in both in Connecticut and there was the clubs. They really want to do everything they can to support clubs and give them the tools they need to succeed. And there's evidence, if you look at QST and the other publications, you'll see they're making efforts to do that. Keep in mind the division convention will be here in 2024. Thank you for your time.
Okay, thanks, Pat. I think that's all I have. So we've asked Glenn, WA7X, to MC the presentation tonight. Looks like we got 5 people sign up. Anybody else have a presentation that doesn't have their name on the list? No? Okay. Okay. So I guess you can have 5 or 10 minutes as needed and enjoy.
All right, well, let's get the antenna go vertical and keep the range going here. I'm Glenn, WA7X. That's my real call sign. I didn't get it as a vanity. My wife's call sign is KI7DX. That's also not a vanity. That's just what we were given. So we lucked out. And she's been a ham over 25 years. I think I've been 57 years. It's hard to imagine. Anyway, Homebrew Night is one of the more exciting nights that we have to see what people have come up with, innovated, and new ideas that sometimes stimulate new antenna growth and new modes and things of that sort. So let's start out with John, WA7PZJ. Come on up, and if you need, I'll hold the mic for you so you can present.
I brought pictures. So.
Oh, good.
Where do you want me?
Right at that table there in front.
Right here.
Maybe you want me to be a bigger?
All right. On the picture here is a picture of this antenna that I saw it on YouTube. There was a ham that made this, and I'm a sucker for antennas. This is the mast. It's a 20-foot fishing pole for deep sea fishing, fiberglass mast. And then I just went over to Home Depot and bought some aluminum angle iron and made myself a spike. So what you see on the screen here is this antenna pounded in the ground. You can't really see what it is. It's It's a 40-meter dipole, basically, in wire, but half of that dipole is helically wound on this. And the other half of it is the counterpoise laying on the ground. And then there is a little 4-to-1. I just bought an LDG 4-to-1. This is my kit that goes with it. So I have my 4-to-1 ballon that I think you could see it kind of, well, not a very good picture. There's another picture here that I'll have Clint show you here. So that's deployed in my backyard. So 2 pieces of wire making the 40-meter dipole. You helically wind this on the full 20 feet of just above the stake. And then you have Velcro that I use to attach the 4-to-1 ballon at the bottom. Go ahead and click to the next picture. Let's see what it says. So there you can see the ballon kind of Velcroed. You can see the helically wound parts starting and then the counterpoise hooked on there. I think the next picture is it deployed in the field. I love to work portable. September 2021, I was portable in the Poconos in Pennsylvania with my IC705 and an end-fed half-wave. Like I said, I'm a sucker for building antennas. This is a 9-to-1 QRP Anand that I built. I haven't had a chance to get out and use it yet. I have a lot of antennas that I play with. And I just took a chalk line and wound 100-ish feet of wire on it. And if I want, I can wind this out to a half wave on 40 and use a different ballon, and and then I just wind it back up when I'm done. Whatever you wind out of this becomes the antenna. The rest of it doesn't really see. So that's kind of a fun idea. So that's what I have. Let's see. This is, like I said, this antenna deployed camping down in the Palisades State Park down by Manti. And I'm usually QRP when I'm portable. I have a plethora of QRP radios. I've been portable in the mountains of Northern California, kind of close to where Dan's from, a little bit further north up by Shasta Lake. He's by Yosemite. But working portable QRP is a lot of fun. So that's what I have. Any questions? Yeah.
The question is on the chalk line, can you put a mark like that, the 6-foot line?
Yes, you can. And if you feel like it, and you want to end-fed half wave on 20, you can mark, for 20 meters. You can do all that. 40 meters is kind of a fun length because it'll work on 20 meters without really even doing anything to it to match it. But this helical antenna, you need an antenna matcher to use it. But I've had it on 80 meters, I've had it on 40, I've had it on 20, I've had it on 17. So, and it works great. One of the comments in the on the YouTube channel, I just had to laugh at. Obviously, an engineer, and I respect engineers. I worked in engineering for 20 years. So I respect engineers, but some engineer spoke up and said, that antenna mathematically won't work. Okay, that's fine. If you want to believe that, I can tell you this antenna works, and it works very well. I don't care if it works mathematically or not. It works.
What gauge wire did you use for the vertical?
What gauge wire was used for the vertical?
This is, what would you say that is?
Oh, I'd say that's 20.
Yeah, I was going to say, I used to work for Unisys, and Unisys had probably once a year the we're getting rid of this crap sale, and I bought 1,000 feet of this Teflon coated wire for like 10 bucks on a spool. So that's what I had, so that's what I used. And I've used it with 100 watts. It works just fine.
When you wound that off the mast, is it wound all the way to the top? Or
Yes.
When it was wound on the mast, was it wound all the way to the top? And his answer was yes.
So, great question. I just put this little hook on the end. And then there's a loop that I've put on one end of my wire. And I just put it on there. And this thing takes 5 minutes to set up. Okay, well, then this is not the antenna for you if you don't have 5 minutes. But, you know, like I said, I love playing with antennas, and I know most of you know, as I look around, I think most of you know K7RJ. K7RJ was my Elmer. And I know he is. Hi, Ron.
Hi, Ron.
But I guess I could blame that on Ron, because Ron loves to make antennas, and that rubbed off onto me. Any other questions?
My question is the helical portion forms kind of an L? So do you go off horizontally with one part of this and then this goes vertical?
No, I just literally hook it on the top there and start spinning the mast and loosely wind it so that I've done it enough that I can kind of judge where it's going to end up.
it doesn't have to be very precise.
No.
Okay. All right.
That was your question.
Yeah, essentially that's it.
Okay.
Very good, John. Thank you so much. Yeah, select a fabulous prize and a roll of tape. Or a roll of tape and a fabulous prize. All right, well, that was a great homebrew project. Really appreciate you showing that to us, John. Now let's see Gary. Alpha Bravo 1. India Papa.
Make sure he steps up here.
Oh, yeah. I thought you had a different call sign, Gary. That's the only one you've ever had. Okay, well, here's Gary. I'm going to let you wear this because I think this is a little more complex than the last one.
Okay. For this year I've been building a radio I called an HFV1, and people who like abbreviations to spell out the first letters of words might like to imagine that it means that it's built around this digital board. Oh, I'll have it. If you go on to the next slide, I can show a bit. That's a high-frequency VFO circled in red there, but really we'll all know that the real reason is that I want to remember our dear friend Gordon, K7HFV. This is a radio built around an FPGA, a field programmable gate array. If you've ever seen Chuck Johnson's car, WA7JOS, his license plate blinks his call sign in code controlled by an FPGA. So the same underlying technology, but I just send the signal over an antenna instead of the light on the license plate. So, can you skip ahead, please? I'll try and go through three things. I want to talk about the design and how I assembled it, and then I'll try and get it to work for you if it behaves well enough. So I'll just go through this very quickly so we don't take too long. Here's the schematic. First slide, just the power supply. Nothing interesting there except it's all linear regulators. I don't like switching regulators around radios very much. Next. And then this is the non-volatile memory for the FPGA so that when it's turned on, it knows what to do. Next. This is the screen that has an LCD on it there, which is in the lower left. And then down here, the analog digital converter used to sample the microphone and some front panel controls and so on. Next, please. oh, this is a bit more interesting. So this is how the RF is generated and received. So in the bottom left, this is a digital to analog converter. Inside the FPGA, I have a it always knows that the current phase of the carrier, and then 80 million times a second, it will add a little bit to the phase depending on what the current frequency is, consult a lookup table to get the instantaneous amplitude, multiply that by an envelope amplitude to get the signal it will put out to the connectors, and then feed that over this bus to the digital to analog converter, and then this section converts the differential signal to a single-ended 50 ohm signal out on that connector there. And it's then 12 nanoseconds later, it will do the same thing with the next sample, and so on and over again. And so that's fast enough that it can synthesize HF directly without any baseband generation being upconverted. And then in the upper right is the receiver section. High speed to digital converters are a bit more expensive than the other way around, so the receiver works a bit differently. It assumes where the signal has already been mixed down to a 500 kilohertz IF, and so it comes in on those connectors, 50 ohm termination, and then into those op amps buffer the signal so that it can drive the weird dynamic impedance of the analog to digital converter there. Then the sampled IF is fed over that bus to the FPGA. Next, please. And then memory and clock. The memory, I haven't actually populated the memory. That I haven't been able to buy the thing yet because of inventory issues. And then a real-time clock. That's kind of important because digital modes like FT8 and Whisper rely on known start times for all the messages, so that anybody who wants to listen is ready to decode at the right time. So that's what the clock is for. And this is more miscellaneous I/O stuff. There's knobs on the front panel, USB. And the oscillator here is temperature compensated, so that's important because the carrier frequency is derived from that, and it stays within a few parts per million of where it's supposed to be. And then to generate the audio inside the FPGA, I run a sigma delta modulator, so I massively oversample the audio to about 25 megasamples, and then that's output digitally over here, and then it runs through this cell and key low-pass filter to block the digital switching noise and pass the analog audio frequency signal out to a speaker or headphones over there. And then the headset connector also has a microphone which runs into this preamp, which gives enough gain to bring mic level up to be strong enough to be sampled by the analog to digital from another slide. Next, please. Well, and then here's the power amplifier stage. This is built on a different board, and it doesn't really work all that well. This schematic doesn't quite match what I've got here built at the moment. There's driver stages, class A NPN there, and then on the screen is showing a push-pull AB, class AB MOSFET pair that never really worked very well. So right now I've ripped that out, and I'm just using a class C NPN final that's a bit more robust, but unfortunately is not linear, so it doesn't work for sideband at the moment, but it's good enough for CW and some digital modes. So yeah, that's about it for the design, and I like to make my own circuit boards when I can, but the trouble is the FPGA I wanted to use needs about almost 400 connections in an area smaller than a postage stamp, and that's just so far beyond any kind of precision that I can manage that I send it off to a factory to get made. Then I have a few photos of putting it together. Can you go to the next one, please? So the accepted industry standard for soldering BGA packages like that is to use a reflow oven or infrared heat with computer-controlled temperature profiles, and then follow up with quality checks using an X-ray inspection station. So people who know me will be not at all surprised to know that I put mine together using an electric hot plate. This was on sale for $14.99 at Smith's, and I also used the cheapest paint stripping heat gun that Harbour Freight would sell me. So next, please. So this is this stencil. There's some of the boards that got sent back from the factory, and so stencil of me putting on the paste. Next. And then I get sent junk mail all the time, and in my mail people send me solder paste spreaders, which are kind of handy to use, so I got one of them to, next please, to spread out the paste on the board. That's what it looks like once the paste is there. Next, please. The next one is. And then now there'll be, that's with the components stuck onto the paste. And then the next one will be after the hot plate is turned on and everything melts, it starts to look like that. And then next. And then after it's got enough added to it and powered up, then it will light up. And then next. Pardon? Oh, a 4-layer board. So yeah, again, it's more than I can make myself. I can do one easily and two with some less friendly language, but 4 is really beyond me. And then after it's programmed, then it will generate IRIF like that. So now I'll try and. So here's a commercial. Radio I'll use as the receiver, and I have it transmitting into a dummy load, but with a little clip lead on one side to make it leak a little bit to hopefully have enough signal to pick up. And sorry, please hold the mic near the speaker so it will try and hear the receiver.
Okay, over the receiver.
Trying to call Gordon, didn't get it quite right. We'll see. I was really hoping that might work, but yeah, okay. Yeah, I suppose yeah. I'm having trouble getting to the other side. So that's it.
Very good, Gary.
Any questions?
Did you write the code?
Yes, it's written in Verilog, and so yeah, I can say more. It's on the web if you want to see more details, but it's sort of a work in progress. It's enough to do some CW and we'll send Whisper, but I don't have the receiver properly behaving yet. So it's kind of I wrote half of it.
Are there libraries?
No, I reused. There's a soft CPU that I reused from earlier projects, but otherwise not much. You've seen pretty much all it can do. So I haven't needed anything fancier than this so far, and then I just gradually work on bits to write.
Now we understand why he works in the computer engineering department.
I work, right, one floor above Mel, the same building, and John.
Willie. Are you going to use those 10 free meals on the gift card?
I'm not sure if it's still valid. I'll have to look it up and try. It's that card is looking pretty dirty by now. I'm not sure if it will still work.
All right. Any more questions?
Thank you.
Yeah, Gary, that's great. It's amazing how far amateur radio spectrum of what people build is. I'll tell you what, after seeing this, I'm going to go home tonight and try to put one together. But, yeah, well, the biggest problem might be to get the pancakes out of the way first. I'd hate to get a little capacitor chip. And here's Chuck. Okay, I'm going to let you wear this space helmet. On your right.
Okay. Well, for Father's Day this year, I received a 3D printer. And it was kind of a surprise because I wasn't really expecting one or hadn't expressed an interest in one. And I went, what am I going to do with it? Well, I'll tell you what, I don't think a week's gone by since then that I haven't made something. So, next slide, Clint. This month's QST has 4 articles in here about 3D printing. So I thought it might be appropriate to talk about 3D printing in case you want to get into it. I know several of you already are. Brett just bought one, I know. Don't see Doug here, but he's big into it. So, next. There's a repository called Thingiverse that has at least 1,000 amateur radio projects. Just go to Thingiverse and type in amateur radio for a search. And here's just a few that I found. So you can print yourself up an ARL keychain. This orange one is all the working parts to make yourself a dipole. There's room for an SO239 and a ballon on there. Make yourself a keyer paddle. The little blue part here is this design. That's to lock your Anderson power poles together. You don't like the knob on your radio, you can make a new one with a spinner on it. A box for your nano VNA. How many of you ever built a project and then gone looking for a box to put it in? They've gotten expensive and you can't find one that's the right size. Well, for about $1 you can print one up. So, next. Good question, and this is the answer right there. You may not recognize what that is, but it's a waffle, and it's 8 inches square. There are different size printers, but this Ender 3 does about 8 by 8 by 8. This is 8 inches square and 1.5 inches thick, and took 16 hours to print. So it's not fast. This is a foot for a ladder. The original foot was rubber, and the tubing cut right through it. And so I made a new one out of a new pair out of plastic. These are some little gear things I made. These little trapezoids fit into the slot here in the key. This was version 1, that's version 2 that I made of those. Next. This is from Thingiverse. So this guy on the left is the bottom for an Arduino Uno board. So it's got the cutouts here in front for the USB and the power connector. And then this part was the lid, and it's got the holes in it for plugging on a shield. And I went, yeah, but I want the whole thing, including the shield, enclosed. So I took the 2 of those and built this. That's an offset. And so this just all clips together. Like that. And like that. And if you stack up the shields higher, you can put in more of these and build it as high as you need. Okay, next. Oh, there's what I just showed you. Next. Okay, here's just some crazy things that I printed up. This little guy here is a test sample that comes with the printer. So you can print it. It's a little doggy. This is a test cube. You print that up, and it's supposed to be 20 by 20 by 20 millimeters, and you print it up and measure it and see if it comes out right. And if it doesn't, there are tweaks you can put in the machine to correct that. These a couple little gears. I don't think I brought those. This, it's hard to see, but it's a shroud for Anderson power pole connectors. So this will hold 2 pair and has the holes so you can bolt it onto something. And it's got the locking holes already built into it here. And if anybody can use that, you can have this. I just printed it for a sample. And Heathkit has these little lever knobs that sit behind some of the knobs for switching your CW and filter in. And the tab breaks off, and since there's no Heathkit, they can be hard to find. This came from Thingiverse and took about 15 minutes to print. So there's your fix. This took about an hour to print. If you're going to do your own designs, you're going to do a lot of measuring with your calipers. This is a holder for your calipers. You can bolt that onto your desk somewhere where it's in easy reach, and you can grab them and quickly take a measurement. So I made a couple of those. Okay, next slide. Okay. There are a number of different kinds of filaments. The most common you find is PLA, and that's a plant-based product made out of corn, and that's the most common, and you find a lot of that around. But I learned from the QST article that it's not suitable for outdoor use. It's not weatherproof, and it's not UV resistant. And I've heard of people, let's see, was it you, Brett, said you put one out in the sun and it melted? I don't know. Okay, so there's another product called PETG, polyethylene something glycol. That is suitable for outdoor use. It prints a little hotter, has a few more quirks that make it a little more difficult to print. ABS is the other common one, but ABS is like drain pipe, and it prints very hot, and you have to enclose your printer to keep the heat in, or your print will fail, and it stinks. So PETG is almost as good as ABS, so that's your trade-off. Now, if you want to just print stuff, you can go to Thingiverse or any one of several other places and download something, and then you put it in a piece of software that's called a slicer, and most of those are free. And what it does is take an STL file. That's what most of your solid modeling puts out, and that's what everything on Thingiverse is an STL file. The STL file is a description in little triangles of what your part looks like, perhaps millions of them. And you run that through the slicer, and it generates G-code, which is an ASCII-based thing, but it drives the 3D printer X, Y, Z, and filament and temperatures and all that stuff is all in the G-code file. And that will be specific to the model of printer you have. So you're going to tell the slicer what kind of 3D printer you have, and it'll generate the G-code for that. What it does is take your model and slice it into little layers that are a fraction of a millimeter high and build that up to perhaps hundreds of layers thick. And no, the filament is about 1.75 millimeters, and he says the thickness of the layers is how big your filament is. No, it's much smaller than that. The filament is normally 1.75 millimeters. The common nozzle size is 0.4 millimeters, and as it oozes out, you're printing layers that are 0.2 or 0.3 millimeters thick. So something that's 25 millimeters high is 100 layers. So it's not fast. You can make anything you want, but it's not fast. Now, if you want to do your own design, you're going to need some sort of solid modeling software. And there's SolidWorks, there's Fusion 360. Those are both fairly complicated programs and expensive, except if it's for hobby or educational use, they're free. But this learning curve is steep. I spent a lot of hours on YouTube watching videos, and just when you think you got it, you don't. You go back and watch it again. There are simpler solid modeling programs. Which one do you use, Brett? Tinkercad. That doesn't have such a steep learning curve. Maybe not as many fancy features either. So the solid modeling lets you build what you want to build. And typically you draw it in 2D and then extrude it into 3D. And then when you get that all done, you save it as an STL file. Then you go send the STL file to the slicer, which makes G-code, and you take the G-code to your printer. And it's not as hard as it sounds, but so that's how you make something. So I'll leave these up here on the table if anybody wants to come and look at them closer afterwards. Any questions? Tom?
So if you had a complex shape or maybe a shape that's larger than can you do it?
Tom wants to know if it's too big, can you print it in pieces? And the answer is yes, you can. Not all glues are friendly with plastic. You got to find the right thing that'll glue them together. This waffle thing was for a neighbor of mine who runs a little waffle business at farmers markets, and he wanted it for advertising. That's before I knew PLA wasn't suitable for outdoors. And he wants a bigger one anyway, and so I'm going to have to split that into probably 8 pieces in order to print it. That's four quadrants, and then a front and a back, because it's got indents on the front and the back, and printing it all at once was a pain because it has to put in support material if there's anything left flying. It's got to start from the bed and work up. So if there's holes in it, it puts in support material, and there was a lot, and it took me 2 hours to clean all that crap out and salvage the part. So, yeah, just about, yeah. Ron?
Do you have any capability to scan an item?
Can you scan an item? I have not done that, but it can be done. In fact, this STL file I got for the waffle was from a scan, and it's complete. It was scanned from an actual waffle, and it's got all kinds of ripples and stuff in it, which is why it has millions of facets. Anybody else?
Yeah. You mentioned it taking a while to clean it out, and then you mentioned things taking like all night to print. How much maintenance is there to the printer itself?
How much maintenance is there to the printer? I haven't done anything except the bed leveling is very critical. You got to get that space between the nozzle and the print bed just right. If it's too tight, it oozes out and squeezes and scrapes on the bed. If it's too big, then it doesn't stick. And that once you get the first layer down and stuck, I haven't had a failure after that, but I've had a lot I've had to start over. I started printing and I go, ew, that went off the rails, and stop it and clean up the mess and re-level the bed and start over. So, anybody else? Okay, thank you.
You know, and so tonight I see a grill being used to cook a circuit board, and I see something to make a circuit being used to make a waffle. So, kind of a neat deal here. That's right. So, I wondered, how big of an Anderson connector has anybody seen? Amps and physical size? Okay. I've got one about that big that handles 150 amps on a UPS. 200 amp. Okay, you beat me. That's big. They're big. Connect 200 amp for an Anderson connector. So now, Doug, KD7 November Zulu Alpha. There's a couple of Zulus up here today, isn't there? That's kind of cool.
No printer or anything, but I took my first foray into building a 49-to-1 end-fed half-wave. Very sloppy, at least I'm a perfectionist, but I think it's very sloppy. But this is my attempt at doing an Unan, 3 240 ferrite cores wrapped with 14-gauge wire and then put into the box. The box was the hardest thing I had to find. You know, I haven't tested it yet, so I don't know. With 3 toroids, it's supposed to handle quite a bit, but yeah. I'm still learning how to solder, and I made a few mistakes, had to take everything out and redo a few things, and I ended up burning my box a little bit, so there are a couple of holes off to the sides or on the edges of where my soldering iron hit. But I'll get this up hopefully within the next couple of weeks and get it tested and see if we can figure out how well it works. I've got everything ready. I just got to measure out the wire and put it up. So, any questions? Again, nothing fancy.
What, you wound the toroid yourself, right?
I did. So there's 3 toroids. The question was, I wound it myself. Yes. Should be 2, so 7 to 2. So you got 2, then 7, and then it crosses, then 7 more. So 1 to 7 ratio.
Where did you get the guidance for?
Off of YouTube. Steve Ellington has several different videos. They were about 5 years old on building this, and I just followed his directions. I bought the toroids. The question was, where did the toroids come from? I bought the toroids off of Amazon. There are multiple places online you can order them, but I was just doing quick search, and I'm buying off of Amazon for pretty much everything that I could. Some stuff I bought locally at Home Depot. I think there were 43, if I remember right. So again, this is my first attempt at building an antenna. It is a little sloppy, but I'm going to enjoy. I enjoyed doing the parts. Biggest problem I had was just getting the parts all at one time so I could put it together.
Just make sure you drill a small drain hole so it doesn't get full of water.
I got 2 drain holes at the bottom already. But yeah, we'll get this up, and I've got everything ready. I just got to stop doing other people's projects and do my own. So, As much as I can. I want to go try 80 and 40, of course. But we'll just see what the equipment I have will work. I inherited some radio equipment, so that's what I'm using. So, and thank you.
That looks very good, and your soldering is actually very good. Don't worry about it. I would say about a year and a half ago we had Mike WA7ARK gave some details on the NFED, and it might be worth going back and looking at him. The other thing is there's online KF7P Metalworks also sells those toroids locally here in Salt Lake, and I know the guy who packs the shipping, and he often gets things out on time. That's Clint, of course. You don't do that? No, he doesn't do that. Yeah, but we do know that they are available locally. So, I know Clint's coming up next, and I thought, well, this is kind of ham radio because it uses magnetic thing, but this is my shirt. It's magnets. Have you ever seen these before? This is the ultimate nerd thing. You just put it on, shake it straight, and all the buttons line up, and they're super magnets underneath the buttons. My wife got it for me. Yeah, you can still get off one or two buttons. It doesn't matter. That's right. Yeah, an alternate job thing. And then the other neat thing is that when you go to Savers or Desert Industries and you want to know if the pans work with your induction cooker, you just flip this out and then see if the pan sticks, and then you got a pan that's usable on an induction cooker. So I think that counts as a ham radio kind of thing. We'll see. How do you attach them to your shirt? They come that way from the factory. It's an off-the-shelf thing. I just got to find a white shirt like this, and it'll make Sundays easier. Mel. I don't know. I haven't done that, but I can tell you that it's an interesting thing in the clothes dryer because it sticks to the drum, and you hear strange clanking noises. So even the washing machine. So I guess it's time for Clint's presentation. You want to come up here and see what do we do here? Here we go.
Okay, as you know, we're streaming to YouTube, which is no excuse for not showing up here. Let me see if I can switch to this other camera so that people can see who's talking. It's not looking very good, but anyway. A few comments. Ron Jones suggested use FreeCAD, which is his choice. Emphasis on the word free. And if you're not quite as adventurous as the guy that built the Ballon, you can get the AWRL kit, which has all the parts with it. But I think that's it's an excellent reason to do something you haven't ever done before, and just source them all your own and wind them yourself. Learn how to solder and source everything. And Ron, along these lines, Ron says that he got a lot more from doing this by doing it himself, and rather than simply putting the stuff together. So buy the kit you want, buy the kit or get all the parts together, but build something. That's what we're here for. And we want to see it next year too. All right, so that's not how you wear it, but it'll work. Okay, so the first thing is this probably dates back from the 80s when I was probably a novice or just barely got licensed. And of course, I've never run resonant antennas. I've never really run resonant antennas in my entire ham career. Let's see, bend that up just a little bit. So my go-to thing has been running ladder line, or right now I run a so-called horizontal loop or lazy loop. So my Elmer, who lived across the street, had this World War II transmitter in his basement, and it had a few useful things in it. Big bread slicers, also called variable capacitors, and a roller inductor. And two of these, you can match practically anything. Now you see this is built into a wooden box. We had some paneling kicking around. I was a teenager still, probably barely in high school. And I built it without this sheet metal. And and I didn't know better, and without something as a good ground, this thing didn't work worth a darn. It didn't tune anything, because what I was really tuning was the individual wires connecting the capacitors and everything else. But somebody clued me in on it, and I found some piece of sheet metal in the garage. I don't know if my dad knew I swiped some sheet metal, and soldered everything down. And this is a tuner I've used I haven't used it recently because I have a newer one, but I've used it for 40 years. I built this about 40 years ago. And at Harback and Radaman, one of these places where you could buy just surplus stuff, I saw this inexpensive CB type SWR bridge and stuck it in there. You know, it was originally in something. And it's stuck back here. So you can hook wires to it or coax, and it served me well for the many, many years that I used it. I since got another tuner Heathkit tuner at a swap meet, and use it more instead because it's a little bit more compact. But I'll hold this up to the camera. Right. And if you look carefully, these knobs here, one says 6L6 and the other says 807 on it. Now, some of you are laughing, and you know why? Because, as I mentioned, this is from from a war surplus transmitter, and I bought a war surplus World War II transmitter at Smith & Edwards back in the 80s, when they still had World War II surplus stuff in the 80s. And these knobs are from that. So, anyway, I'll leave this out to look at it. I think this will handle full legal power depending on the load, because those are pretty wide spaced capacitors. And they're about 350, 400 puff each. I mean, this is from a 400 watt AM World War II transmitter, and 400 watt AM is 1200 watts PEP. So the military probably overrates things by a factor of 2 back then. Oh, you're right, it would be 1600. Yeah, you're right. Now, not quite ham related, but sort of. How many ever heard of the Joule Thief thing? Joule Thief. Now, I know you have, but what it is it's a very simple circuit. It's called a blocking oscillator. This consists of, so as you may know, UARC stores its field day towers at the scout camp in Payson Canyon. One of the reasons they do that is that in exchange, we occasionally teach stuff. Well, this past weekend, we kind of paid the bills by helping teach the radio and electronics merit badges. And in preparation for that, Brett asked me to design a circuit board for a Joule Thief, which is a simple circuit consisting of a switch, battery, an inductor, a transformer wound on a ferrite bead, resistor, transistor, and LED. Years ago, he did this on perf board, but it'd be a whole lot easier on a PC board, so I designed the PC board. It took about an hour and a half, did it in KiCad, whatever you want to call it. Now hold this up really close to the camera. There's not much to it. Push the button, the light goes on. And the reason it is called a Joule Thief, spelled Joule, is because this, what a lot of people don't realize is that as an alkaline battery, when it gets down to a volt, still has 25% of its life left in it. This circuit will run down to about 0.8 volts and light up an LED, which requires a little over 3 volts. And the reason it does that, it's an oscillator, turns off the transistor, turns off really fast, and causes the coil to put a kick out, which without the LED across it, probably go up to like 60 volts. So the LED only needs 3-ish volts, so it goes on. And this is what we had the scouts build. Now it's very interesting to teach a bunch of, anyway, how young would they have been? Like, 10 to 21 year olds, mostly in the lower range, how to solder. But what is interesting is assuming they're engaged, and a lot of them were engaged, it's interesting to see how many people, when they know they can do something, it just changes their whole demeanor. Like, I don't know how to solder, I don't know how to do electronics. Well, it's not that hard. You just melt stuff, get things wet. You know, that's essentially what soldering is getting things wet, you know, with metal. And it's really not that hard, and they had something they could take away that actually worked. And I don't know, we probably put together over
100 kits, and we had like 6 left.
Yeah, over 90 of these were built in the course of an afternoon. Chuck was there helping. Brett was occasionally there because he was busy with other duties, and another guy, I can't think of his name.
And David Sauce, he was with the radio.
Yeah,
Chris was the other guy.
right. So.
And they all worked eventually.
Yeah, and we got every one of these to work eventually. The hard part is this enameled wire. It's solderable in quotes, but you have to really put the heat on it. 5 seconds with a bit of flux, and it burns right through. But anyway, a super simple circuit. And if you ever want to build something simple or show something that can be built simply to someone else, look up Joule Thief, Joule. There's a Wikipedia page on it with the schematic, and there's hundreds of different varieties.
We had batteries, holders put in backwards, transistors put in backwards, diodes put in backwards.
Yeah.
And conductors wired crossways.
Yeah. I mean, as much as you try to tell, when there's 40 or 50 kids there, not necessarily paying attention, things get put in backwards. The problems happen, but as I tell them, it is better to build a project that doesn't work the first time. Now, why is that? You learn something, and I would hope if they took nothing else away, that you fail, you figure out what you did wrong, you make it work. You learn way more doing that. Anyway, so that's. That is how we spent this past Saturday. Yes, Brett?
I have another 100 boards if anybody wants to burn themselves.
Oh, yeah. Brett says he has another 100 boards around. So, I mean, ordered 200 boards. They came out like, what?
$29 for 200 boards.
Yeah, 29 plus about that much for shipping. Yeah, so 60 boards, 200 boards cost $60, So it's amazing what you can get on the internet these days. But anyway, if I were to design the board, I'd make a few more pictorials showing where wires go, like long lead, short lead, and green lead and red lead. But it's not bad. Anyway, that is it. So I will hand it back to you, Glenn.
That has a couple of neat things with it. Working with the Scouts, which I think goes along the lines of what Pat was saying. Let's see if we can encourage young people to get interested in amateur radio. So that was a good thing. And I think that having a simple circuit that's achievable is spectacular. So good on all of you who participated in that scouting event. That was really nice. And I do agree with Pat. How are we going to get more people on ham radio? Paul does 10 meters, which has really been a great thing. I know you've been pushing the 6 meter group as well, and appreciate that.
I have a question.
Okay, question for Clint. Yeah, I'll stay there and repeat the question.
Clint, on the tuner that you've got there, is the coil silver plated?
It is.
Yeah, so the question was, is the roller inductor silver plated, and it in fact is.
Yeah, you can.
Yeah.
Harnessed in fact.
Well, military, amazing it wasn't solid. Some of them solid.
Yeah, I have a ribbon transfer inductor from a Collins aircraft tuner. And that is the way to go. It literally puts the silver ribbon onto a silver plated drum, and that is the very best inductor you can make. Because unlike a roller inductor, you don't end up with an auto transformer sticking out the end, which reduces the Q and causes high voltage and tuning. Because the coil physically disappears when you unwind it. It's gone. It doesn't exist anymore.
That's pretty neat. I've heard them called banana slicers, which I think they'd be easier than bread. But
yeah, true.
And as the first time I saw this, I thought you had raided your furnace duct from your dad, you know. And the furnace still worked in the house, so that's good. So all of you who are here and those of you on Zoom, you can see how exciting amateur radio. It has a lot of different aspects. Emergency communications, DX communications, community service, electronic learning, and of course projects. And beautiful end-fed dipole put together. And Gary, like I say, I'm going to go home and build one tonight. I'm glad you put all that detail in there, and the schematics are on the YouTube page, so we'll just be able to duplicate it without much difficulty at all. And I don't know about many of you. I really like to watch YouTube, and there's a lot of people who are now streaming Disneyland. There's got to be a half dozen people. I've probably ridden Pirates of the Caribbean now in the last 3 weeks 50 times. But it's real interesting to see with 5G how people are now beginning to use that. That's one aspect that is concerning is that cellular telephone is taking over everything. And then with the low Earth orbiting satellites, and T-Mobile, there's going to be a ubiquitous thing. But this leaves us with a little bit of a challenge in amateur radio. You know, radio sites are becoming scarce, and people aren't as interested. So we've got to look at some of these aspects to be able to help. Morris.
We talked about emergency communications here just a second ago, and this Hurricane Ian that went through the Caribbean and through Florida. The ham radio was a major factor in communications for the first few days after the hurricane went through. And it doesn't get enough airtime on television because it is real life-saving that we as amateur radio operators do just because it's there, because we want to help people. That's all I want to say.
No, and your point is well taken. In spite of the fact that the space X things are easy to set up, you still have to have the technical knowledge to do it. And that's the thing that is invested in all of you as amateur radio operators, is to have that self-sustaining knowledge. And I'm so glad to be part of the ham radio community and be able to support those different aspects of it. Anyway, I think that's the end of what we have. We got 10 minutes before. Everybody get your roll of tape and prize that participated. And thanks again for being here. Clint, you have any closing remarks? That's it. Okay, thank you again so much. Take care.
Thank you.